Hello everyone, in this video we're going to be solving a logarithmic equation. I'll be presenting three methods. Let's start with the first one. But before we get started, I just want to say a couple words. I know this problem is considered an easy problem, but I think it's important in terms of illustrating the different methods and the formulas we use. So it's kind of like using the formulas for logarithms, because the definition of logarithms and using the formulas effectively is very important. Okay, let's get started with the first method. So my first method basically involves writing the 1 as log 10. Because we're working with base 10, by the way, some of you guys are probably going to be upset about it, but log is used with base 10. If I want to use base e, which is the natural logarithm, I'm going to use ln for logarithm natural or natural logarithm. Great. So now we can condense the expression on the right hand side, which means that log a plus log b can be written as log a times b. So I can write this as log x plus 1 equals log of x times 10, which can also be written as 10x. Great. Now, since the two logs are equal and they have the same base, now if they didn't have the same base, obviously this method would not work. We would have to do something else. And I think I've done quite a few problems, well, not quite a few, but just a couple maybe, on different bases. But anyways, since the bases are the same, we can safely say that the arguments are the same. So from here we can write 10x is equal to x plus 1, and this is a very easy linear equation with variables on both sides. So we're going to subtract x, that's going to give us 9x equals 1, and division is going to give us x equals 1/9. Now, one of the things that you need to pay attention to if you're solving a logarithmic equation is the domain, because you have to make sure that the answer you find works in the original problem. What is that supposed to mean? Well, we do have x plus 1, so x plus 1 is supposed to be greater than 0, and x is supposed to be greater than 0 in order for the logarithm to be well defined. But this implies x is greater than -1. This implies x is positive. So x is positive already covers this x is greater than -1, because we're looking at the intersection. So we are only looking for positive solutions, and 1/9 is a very, very positive number. Therefore, it is going to work. Yay! Our only solution works in this case. Great. Okay, let's go ahead and take a look at the second method. Alrighty. Now, my second method, and of course, I want to start off with the original equation all the time, so you can see where I come from. So this is my original equation, and for my second method, I would like to put the logs on the same side. You know why? Because I have a number, and it's better if I have the logs together, so I can use the formulas. Which formula am I talking about? I'm talking about, again, condensing this expression. I have difference of two logs with the same base, so I can write it as a log of a quotient, right? So again, the formula goes like this. Log a minus log b can be written as log a over b. Of course, in this case, the absolute value, we have to make sure a and b are positive, so on and so forth. I'm not getting into those details. I hope you don't mind. But yes, this is called condensing. If you do it the other way around, it is called expanding. Okay, so I can condense this and write it as log x plus 1 over x equals 1. Now, you have to think about this for a minute. Like, either use the definition or think about it. Like, log of which number is 1? Well, it needs to be the same base, so it is 10, right? Log 10 equals 1, and we used it in the first method, remember? So this must be 10. Okay, that thing must equal 10. And from here, we get x plus 1 over x equals 10. And by cross multiplication, we get x plus 1 is equal to 10x. And guess what? We get 9x equals 1 again, and x equals 1/9 again. Yay, great. So we got the same solution. Of course, we should be getting the same solution all the time. We already checked the domain before. Remember, x equals 1/9 works. You can also substitute your findings into the original equation to see whether they're going to make the expression positive or negative. But in most cases, it's better to check with inequalities. It's a faster method most of the time. All right, great. So this brings us to the end of the second method and to the beginning of the third method. Okay, let's talk about the third method now. Now, my third method involves something slightly different. That's why I like this method. And that's why I like logs, because you can use different methods. You can use the exponential approach, or you can use a directly logarithmic approach. You know that logs or exponentials are obviously related, right? So my original problem is log x plus 1. You know, one math book said to the other, said you've got lots of problems. Okay. Anyway, so this is the original problem, and what I'd like to do here, I want to consider the base. Even though it's not written when it's base 10, I'd like to write a little 10 here, and I'm going to use the definition of log. What is the definition of log? So if you have like log of x with base b, and that is equal to a, this implies, and that's kind of like a, you know, two-way implication, if and only if, or some people write it as IFF. This implies that b to the power a, so you start at the base, you go to the other side, and you come back. That's going to be your answer. That's how logs are defined. So if you didn't know anything about the logs, this definition actually would tell you what you need to know. A lot of problems can be solved just by using the definition. That's why the definition of logarithms is super duper powerful. Great. So let's go ahead and use the definition here then. I'm going to start off with the base 10, and I'm going to have to go across to whatever is on the right hand side. So that's going to be like 10 is going to be my base. The exponent is going to be right here, the answer. So 10 to the power log x plus 1 equals x plus 1. I know that this equation kind of looks complicated, but I think it's important in terms of illustrating the methods used here, because we're going to separate this, right? So whenever you have something like a to the power x plus y, you know that you can write it as a to the power x times a to the power y. And this is a very powerful formula for solving and simplifying exponential expressions. And exponential expressions, as you know, are fun. Anyways, I talked too much, I know that, so I'm going to continue. Anyway, so separate these two things, and you're going to get 10 to the power log x times 10 to the 1, which I write as 10. Now, we can divide both sides by 10, even though that's not super necessary. But what am I going to do with 10 to the power log x? That's the problematic part. So there's two ways to handle 10 to the power log x. Suppose you didn't know what it is. A lot of folks probably already know this by heart, but suppose you didn't, right? Let's go ahead and call this y, and you know y, right? I like the variable y. So I'm going to log both sides. Log 10 to the power log x equals log y, and then I'm going to move the log x to the front. Log x times log 10 equals log y, but log 10 is 1, therefore log x equals log y, therefore x equals y, or y equals x, which means this expression is actually nothing but x. Great. So this is supposed to be x, and then from here I'm going to be getting my equation. But before that, let me show you another approach that you can use to figure this out. So after writing 10 to the power log x equals y, you can kind of think about it in terms of the definition of logs, right? So what did we say about logs? So we said that log 10 goes here, and then the y is gonna go here, and the answer is gonna be the exponent, right? So by using the definition backwards, we can safely say that. But this is nothing but log y, so log y equals log x is gonna give you the same answer. To keep a long story short, this is x, and from here you're getting 10x equals x plus 1. Awesome. Let's subtract x from both sides and get 9x equals 1. By dividing both sides by 9, we're going to be getting x equals 1/9. And this gives us the exact same answer. So let's go back to the original problem. Log x plus 1 equals log x plus 1. Let's go ahead and replace x with 1/9 and see how that works. So I'm going to replace x with 1/9, and that's going to give me 10/9. And what is log of 10/9? I can basically write it as log of 10 minus log of 9 using properties of logarithms. But log 10 is 1, so it's going to give me 1 minus log 9, right? Okay, great. So what is that supposed to mean, or what am I having on the other side, right? So now if you plug in 1/9 on the other side, you're going to get log 1/9 plus 1, but they don't seem to be equal, right? Well, no worries. We can still use the same strategy here. Log 1 minus log 9 plus 1, but log 1 is 0, remember, because any number to the 0 power equals 1. So that's going to be 0, and you're going to get the exact same answer. And this brings us to the end of this video. Finally, yay. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment. I hope that this wasn't a long video because I had to present 3 methods. Please let me know what you think. I'll see you tomorrow with another video. Until then, be safe, take care, and Bye-bye.